Welcome to solving second-degree equations with factoring. Now I want to solve for y, and to do that I'm going to factor this. So now the first thing I want to do is see if there's a common factor. And you see 77, that's 7 times 11, right? And neither 7 nor 11 go into 90, which is 9 times 10. And 169 is 13 times 13, so we have all of these things are mutually prime pretty much. So I can't reduce this at all. So that's going to make this rather difficult. Alright, so let me just copy that. I'm going to put it into a nice text box. Okay, here we go. So I want to, well, first of all, I would like to get rid of this negative, so I'm going to divide everything by negative. If I divide the left-hand side by negative 1, I get 0. And if I divide this by negative 1, I get positive, positive, and positive. Look at that. And I'm just going to rearrange this. I'm just going to put this right there. Okay, so I've kept the signs and everything when I rearranged it, and everything's fine. So now we're looking for the factors of 90. There's quite a few of them. There's 5 times 18, there's 9 times 10, there's 3 times 30. So yeah, that's going to be lots of fun. Anyhow, and 77 is going to be easy. That's just going to be 7 times 11. Let's try 9 times 10. And for the 77, we'll just do plus 7 plus 11. Okay, so we have 99 and we have 70, and for the first shot it worked. And yeah, I could have been totally lying to you. I could have figured it out on the side, but I didn't. I'm telling you, this is just a very happy, lucky coincidence. Now, when you have big numbers like this with many factors, not very often that it works out on the first try, but this one did. There we go. See, 9y times 11 is 99y, and 7 times 10y is 70. 99 and 70 is 169. It all works out nicely. So we set up our two equations. Now 0 is equal to 9y plus 7 times 10y plus 11. That means, like, if 0 is equal to a times b, that means either a0 or b0. Now, because these have variables inside it, it means sometimes this is 0, and sometimes that is 0. So sometimes the 9y plus 7 is 0, and sometimes the 10y plus 11 is 0. So all we have to do is set these up accordingly. So 9y plus 7 equals 0. I'm just going to remove the brackets. I don't need those anymore. And 10y plus 11 is equal to 0. And then I just want to solve for y. So I want to get rid of that 7. I'm going to subtract 7 from both sides, and that gives me 9y is equal to negative 7. And then I'm going to divide both sides by 9. So that gives me y is equal to negative 7 divided by 9. And that doesn't reduce at all. And over here, I want to get rid of the y alone. So I'm going to subtract the 11. I want to get my 10y's alone, so I have 10y is equal to negative 11. And then I'm going to divide both sides by 10. And that gives me y is equal to negative 11 tenths, which is an improper fraction. And if you like, you can write that as a nice mixed number. So negative 1 and 1/10, which is fun. That works nicely with tens, by the way. Okay, that's the only number that works with, I think. So y is equal to negative 1 and 1/10, and y is equal to negative 7/9. Now we have to put the smaller one first, okay, otherwise the program gets a little upset. It expects the smallest one first, as you should expect the smallest one first. Alright, so I'm just going to pop that into my answer and see if it's right. So here we go. Let's just make sure there's no extra spaces, because the program, unfortunately, does not deal with the spaces very well, because we need to have a space here, so I can't just remove all the spaces wholesale. Okay, and let me just make sure the sound's working, so we can all hear that. Yay! Okay, so it works. Alright, so that's another example of how to factor second-degree equations using, not factor, but solve second-degree equations using factoring. Have an excellent day.